Hello everyone, thank you for watching our presentation. Our group is working on span click and clickbait detection. We decided to use R and BERT model to complete this work and compare the advantages and disadvantages between these two models. Here's some real-life example, and here are some headlines from our dataset. The data distribution is specific. In the specific dataset we used is listed here. Among them, in dataset 1, the number of news headline and span is relatively even. In dataset 2, the amount of span is significantly less. This will cause some problems, which will be mentioned later in the conclusion. We split these two datasets into a training set and a test set at a ratio of 4:1. The specific data of the training dataset and the test set are also listed here. First, we decided to build a vocabulary dictionary in order to transform the dataset into a form which the model can understand it. The maximum size of the dictionary is 10,000 plus 1 unknown words and 1 pad for fill the empty. So it's total 10,002. We use two different models. One is the special form of R model by LSTM. Another one is the combination of BERT model plus by LSTM model. In the example of by LSTM model, we can see there are two hidden layers. One is forward and one is backwards. Because of the task is an English text classification task, so we only take the two final cells as the output. And this is the construction of by LSTM in our project. We set the sentence size as 32, so the hidden layer will be 128. This is an example of BERT model, and we split each word from the sentence, and for each word we transform them into three different vector: word vector, sentence vector, and contextually dependent vector. And these three vectors will be the input of BERT model, and we will dealing with the output by using by LSTM as the first model. Here are some results and the specific data calculation method of the two models in test set 1. We use the confusion matrix to calculate precision, recall, and the F1 score. The final result of test 1 are listed here. We can see loss coverage very quickly, but the loss of BERT model has been some fluctuation. The final F1 score and the accuracy of the BERT model are both higher than the R model by 2%, and the BERT model will become more stable after experiencing fewer approaches. To conclusion, when the data quality is high and the dataset is relatively simple, these two models are not much difference. But as mentioned earlier, in dataset 2, the amount of span and the amount of news are out of proportion. In this case, both models performed poorly. Therefore, in order to achieve the desired effect of this model, the amount of data must be very large. But overall, the BERT model still performs a lot better than R model. So we think the BERT model is more suitable for dealing with text classification problems. Due to limited time, many ideas could not be realized. For the future work, we will try to increase the dataset capacity, like 10 times or 100 times in the future. And we will see if the model will get same effect or not. On the other hand, we will also try different models other than BERT or RNN model. We will conduct more in-depth comparison to draw conclusions. Here are some references. Thank you for watching.